we're going to write exponential growth. Exponential growth. So, like I wrote it in the center at the very top. Yep, on the back. Yes. On one side, put exponential growth. So we're writing on the back. Yeah. So on one side, write exponential growth at the top. And let's draw our exponential growth graph. So we've got a coordinate plane. And our exponential growth graph will look like this. From left to right, it's increasing. So we were looking at our geometric sequence equation earlier in the week. Oh, what did I do? A(n) equals A1 times R raised to the n minus 1. Where A(n) is the nth term, A1 is the first term, R is our common ratio, and n minus 1 is 1 less than the number term we are looking for. So this is our geometric sequences function. We're going to use this function to develop our exponential growth function. What's up?
Oh, sorry, I was reading the book.
Okay. So our exponential growth or decay function, it starts out like this: y equals ab to the x, where y is the term, the amount we're looking for. A is the initial value, or the initial amount. B is going to be our growth rate, and x is the time that we're looking at. So our growth rate, what? Our growth rate is b, and that is equal to 1 plus r, where r is the same r, same thing. R is our common ratio, or in other words, it's the rate of growth. The rate of growth. So now, just like what we were doing before with that worksheet, I know that B equals 1 plus R. So I'm going to plug in 1 plus R in for B up here. So now my exponential growth equation is going to equal y equals a times b, which again, b equals 1 plus r, 1 plus r raised to the x. This is my exponential growth equation. Okay, so that should cover half of your paper. Now let's look at the other side. And we'll talk about exponential decay. Decay. Exponential decay. So again, we'll start by drawing our graph, which is going to look like this. From left to right, it's decreasing. Left to right, it's decreasing. Okay, and again, we'll write down our geometric sequence formula. We don't have to label it, but let's write it down. AN equals A1 times R raised to the n minus 1 and let's write down our exponential growth and decay function, y equals AB to the x this is our geometric sequence equation. And then this one is our exponential growth and decay equation. So for this case, B is now going to be we're looking at exponential decay now. So B, instead of being our growth rate, B is going to be our decay rate. So our decay rate, B, equals, this time it's going to be 1 minus R. And so when I want to write my exponential decay equation, I replace 1 minus R in for B. That becomes Y equals A times 1 minus R raised to the X.
What's that? Exponential.
Exponent?
No, where it says exponential.
This?
No, the other one. Where it's the other side.
Yep. Okay. Let's take a couple minutes, finish copying that down. It's just the same thing we talked about yesterday. Okay. So once you guys are done copying that down, let's go over 2 of these problems. We'll go over 2 of them together.
What? What are we doing?
We're going to go over 2 of these problems together. We're going to go over a growth problem and a decay problem. So let me open up this. So most of you wrote down whether it was growth or decay for each of these. So can someone tell me one of them that's a growth problem? Yeah, the first one. So let's do that one together. Huh? What?
We did the first one together.
I don't think we did. Pretty sure we didn't. Oops. Did not mean to do that. Okay. Okay. So we just decided this one is a growth problem. Growth problem. So now let's walk through. What's our initial amount for this problem? Jasmine, what's our initial amount?
130,000.
Yeah, 130,000. And then, Gadiel, what's our growth? What's our growth rate? Huh? Yes, 6%. How do we write 6% as a decimal? Okay. So now we need to use our function. So remember, our growth function is y equals a times 1 plus r raised to the x. So where a is our initial amount, r is that growth or decay rate. It's going to be our growth rate. And x is the amount of time. So we write that function down here, so we get y equals, what's my initial amount again, Jasmine?
1,000. Oh, we're still at one. Oh, it's 130,000.
And then inside, I saw a lot of people not do this part where we have 1 plus. Have to remember that. 1 plus my growth rate, which is 0.06. And then what's the amount of time that we're looking at? 10 years. So that's my function. And then all I need to do is plug it into my calculator and out pops the answer. So someone plug that in and tell me what you get.
It's mostly really slow.
Yeah, so it's going to be easier to use Desmos though than a different kind of calculator. What do we get? You can just read the numbers one by one.
232,810. 0.2006.
So that is dollars. $232,810. $232,810.20. What? What do you mean? It's okay. It's okay. Yeah. Yeah, number 2 is decay. So do you want to do that one together? Okay. Decay. So this guy is losing 20% of his hair each year. I know, I don't know why they put a smiley face. I mean, maybe he wants to be bold. But if he currently has 1,546 hairs on his head, apparently, about how many hairs will he have left in 10 years?
None. You had 0.
Let's try it out. So what's my initial amount?
1,046.
And what is my decay rate? 20%, which is what as a decimal? Huh? 0.2. Yes? Or 0.2. So now let's write our function. Remember, it's going to be y equals a times 1 minus r raised to the x. Yeah, keep going. Plus. Yeah, parenthesis. Is it growth or is it decay?
Oh, decay. R.
Not r minus 1, but the other way around.
1 minus R.
Yes, 1. Yeah, the 1 will come first. 1 minus r raised to what?
10.
Yes. Oh, and what's r?
Oh yeah, what is R? I just wrote R.
What's r?
0.2.
Yeah, 0.2. Okay, so let's put that in to our calculator.
Is it 156?
I don't know. Yeah. Yeah. So he's going to have 166 hairs in 10 years. Poor guy.
That's kind of sad.
So you can write 166 hairs. Okay. So you guys have got 15 more minutes. Let's work through the rest of these problems. Seems like you guys got it now. Any questions? Nope. Okay.